So in today's class, we shall cover Introduction to Java. So in Introduction to Java, I'm covering a few topics. Those are Java Essentials, JVM, Java Features, Creation and Execution of Programs. So first, let us see what is Java. So Java is an object-oriented and platform-independent language. Okay. Its object model is simple and it can be easily extended. And it provides JDK. JDK is Java Development Kit. That contains tools for developing and executing Java programs. And it also provides JVM, which is a Java interpreter that executes bytecode. And Java has two types of constants and 8 types of data types. So Java provides a feature called as typecasting that explicitly converts a value of one type into another type. And it provides symbolic constants that may appear very frequently in a number of places within the same program. So this was the introduction to Java. Now let's move Java Essentials. So what are the essentials of Java programming? Number one, it is a high-level language. So Java is known to be a high-level language that supports unique features, and it is quite similar to C and C++. Number two is bytecode of Java. So a bytecode is nothing but intermediate code that the compiler generates. So this code is executed by JVM. Number three is JVM. Okay, so what is JVM? JVM is Java Virtual Machine. So let me tell you what is a bytecode actually. So a bytecode consists of optimized set of instructions which are usually executed by Java runtime system on a special machine which is called as JVM, Java Virtual Machine. And a JVM is a bytecode interpreter. It performs line by line execution of bytecode. Okay, so Java has a neutral architecture since it allows programs to run on different platforms. And the Java compiler generates the bytecode that are neutral architecture in order to achieve the capabilities of cross architecture. So these instructions can be interpreted easily on any platform, translated into machine code. So Java runtime environment contains JVM, class libraries, and different supporting files. Now there are many versions of JDK, and they differ in case of platforms like Windows and Linux. So JVM belongs to JRE, that differs in case of OS and computer architecture. So Java cannot be run if JVM is not available for the particular environment. So you can see Java source code converts into Java bytecode, then JVM. So this is called as Java runtime development. So Java source code contains the simple code that is easy to develop and understand. So the bytecode can be run on any platform. Therefore, it is WORA. What is WORA? Write once, run anywhere. So JVM allows to convert the bytecode into machine code. So JDK, that is Java Development Kit, it contains the tools like Javac, Java, etc. So they are of various versions used on different platforms. And JVM, that is Java Virtual Machine, it is a Java interpreter that executes bytecode. And the interpreter reads and translates the entire code into machine code. This translated code is then executed by the machine. So this machine performs all the functions of a computer. And the type of Java interpreter to be ported on the machine must be compatible with the machine and its operating system. So the virtual machine code is different for different cores. It is different for different computers, and it acts as an intermediate between the virtual machine and the actual machine. So it provides virtual machine implementation for Microsoft Windows 95, 98, NT, or Solaris operating system. And the process of translation of a Java program into bytecode simplifies the execution of a program in various platforms. So, due to this, the Java is said to be platform independent. So, I have explained you why Java is said to be platform independent. And execution of a Java program by JVM makes the program more secure and portable. So JVM also solves the issues related with web-based programs. So, however, sometimes interpreter becomes inefficient due to the hotspots and due to the consumption of large amount of time for interpreting. So, a compilation technology called as JIT. What is JIT? Just in time. It has been newly introduced for virtual machine implementations. And this technology provides JIT machine executable codes. Another technology, which is called as hotspot technology, also improved the performance of JVM. So, with the help of a figure, I will show you how JVM handles translations. So this is the figure which shows JVM handles translations. Now let us move on to architecture of JVM. So I will show you JVM architecture. First we take JVM API. So here we write interpreter and here class loader, memory management, diagnostic, JIT. JIT is just in time.
Yes.
So now I will explain you everything about JVM architecture. So in this architecture, the Java API encapsulates the interactions occurring between the JVM and external programs. And the class loader over here, it loads all the Java class files to be translated. Memory management ensures efficient usage of system memory by the application. So, whenever a program requires memory, it allocates some part of new or unused memory to it. And the diagnostic component ensures RAS feature, which facilitates reliability, availability, and serviceability. So it generates multiple outputs from various portions of JVM and JIT. So JIT interprets one bytecode at a time. Operating system interface abstracts other components of JVM from its platform. So first let us understand about class loader. So class loader is a mechanism that performs loading of classes and interfaces into JVM. So when a program attempts to invoke a method of certain class, then JVM checks whether the class is already loaded. If not, the JVM uses class loader to load the binary representation of the class. Then the next is JVM API. So the JVM API is used to encapsulate the various interactions between the JVM and external programs. So some of the functionalities supported by this component is number one, it handles all the command line arguments that have been provided by the user at the time of JVM startup. Number two is it implements and presents various private JVM APIs used by the classes of core Java. Number three is it helps in creating and initializing the JVM using invocation API. So it constitutes JNI. What is JNI? Java Native Interface API. So which helps in interacting with the native code that is required to create a JVM. And it presents public JVM APIs, which includes JVMTI. JVMTI is JVM Tool Interface. So then number three is it implements in creating and initializing the JVM using invocation API. So it constitutes JNI API. JNI is Java Native Interface, which helps in interacting with the native code that is required to create a JVM. Number four is it presents public JVM APIs, which includes JVM-TI, that is tool interface, and JNI, that is Java native interface. And it provides interfaces for debugging and monitoring the JVM tools. So this is all about JVM API. Number three is operating system interface. So let us understand what is operating system interface. So it abstracts the other JVM components from its platform and it helps in developing other JVM components as platform independent. For example, when a vendor like IBM creates a JVM for various platforms, then the user just need to replace the OSI. What is OSI? Operating System Interface. Then number four is just-in-time compiler. So what is just-in-time compiler? That is also known as JIT compiler. So it reduces the interpretations of calling methods, thereby enhancing the performance of Java applications without the use of JIT compiler. So JVM has to interpret a method as many times as it appears in a program. Then number five is diagnostics. So the diagnostics component ensures RAS feature which facilitates reliability, availability, and serviceability. So these features helps in finding the reasons for the occurrence of a problem by tracing the JVM runtime functions. And the result is generated from different portions of the JVM and JIT compiler. Then number six is memory management. So these are the different components which we are listing. So number six is memory management. So memory management enables the Java applications to employ system memory efficiently. For example, when a Java program or a Java application needs memory, that is called Java heap or simply heap. So it also manages garbage collection. And in garbage collection, the part of the memory that has not been used for a long time is either reclaimed for later range or sent back to the operating system. Number seven is interpreter. That is Java interpreter. So it enables reaching and understanding of bytecode files, thereby executing application programs and applets. So it is a Java application launcher. So the first starts JRE, then load of the specified class, and later it invokes the main method of the current class. So this is all about architecture of JVM. Next, moving on to features of Java. So now let us understand about features of Java. So Java possesses a few features which makes Java powerful, object-oriented, and popular programming language. Okay, so number one is object-oriented. So what do you mean by object-oriented? So Java is said to be object-oriented since everything in it is object-based. Its object model is simple and it can be easily extended. And the second feature is compiled and interpreted. So Java is said to be compiled and interpreted since it combines the features of compiler and interpreter. Number three, it is platform independent and portable. So Java is said to be platform independent and portable since its program can be moved and run on any computer platform. Number four is distributed. So Java is said to be distributed since it enables the user to create applications on network. Number five is it is robust and secure. So Java is said to be robust and secure since it provides exception handling mechanism and safeguards, performs strict compile time and runtime checks, and it prevents unauthorized access. Number six is small, simple, and popular. So Java is said to be small and simple language as many redundant features like go-to statements, pointers, operator overloading, multiple inheritance, etc. are not supported by Java. And Java is said to be one of the most popular language as it is modified on both C and C++ language. Number seven is scalability. Scalability and performance. So Java increases scalability and performance of the system. Number eight is it is multi-threaded. So Java is said to be multi-threaded since it has ability of performing multitasking. And the last feature is interactive. So Java is interactive in nature and it allows a computer to perform remote activities while performing any activity locally. Now let us see what is the process of creating and executing a Java program. So a Java program can be successfully created and compiled in three steps. Number one is writing the source code. Number two is saving the code. Number three is compiling the code. So how can you write the source code? Source code can be written in text editor like Notepad. Okay. Then what is saving the code? It can be saved using class name followed by Java extension. For example, simple dot Java. So this is saving the code. So with the Java extension, you can save the code. Then how to compile the code? To compile the program, run the Java compiler javac with the name of the source file on the command line as you can give it as javac simple.java. So if the syntax is correct and no errors have been detected, then the Java compiler creates a file called simple.java containing bytecode of the program. Now, what is the process of executing a program? Standalone applications are run using interpreter. So for this, type the following commands at command prompt. Like you type Java simple. After this, the interpreter searches the main method in the program and begins the execution. So after performing the execution, it displays the desired result as output. Now let us see the structure of Java program. So a Java program consists of one or more classes. Only one of these classes defines the main method. Okay. A class consists of data and methods that operate on the data of a class. So I will give you the example of a class. You have class and instance variables. Let's say this is method ABC. Now we give local variables instruction. Then method XYZ. Local variables instruction. So this is how class is created. So the general structure of a Java program is like this. First, documentation, then package statement, then import statement, then interface statement, and then class definition. Followed by main method class definition, we open the braces, main method definition, close the class. This main method is mandatory. And this one is suggested. Okay, so let me explain about each one of them. So first is documentation. So this documentation section consists of set of comments about the program, including the name of the program. And this section basically helps in understanding the program. For example, we give double slash. Double slash is used for a comment, single line comment. So this is a simple Java program. So this is documentation. Then next is package statement. So what is package statement? This is the first statement in every Java program. It tells the compiler that the classes defined here belongs to this package. So this statement is also optional. For example, I will show you example of package import java.io.asterisk. This is a package. Next is import statement. So the import statement is optional and it tells the interpreter to include the classes from the package defined. And this is the next statement after the package declaration, but should be written before defining a class. There may be a number of import statements. Okay, like how to import. So this is the example of import, and I will give you the example of package. That is, we give package my pack. This is the package example. This is import example. This is documentation example. Next is interface statement. So the interface statement defines method declarations without body for the subclasses to provide implementation for them. And this is optional. It is used only if multiple inheritance is required in the program. So let us give an example of interface, that is interface EX. Now the next is class definition. So this section consists of number of class definitions where each class consists of data members and methods. And the number of classes required are based on the complexity of the problem. Let us give an example of class. Class simple. Now coming to the mandatory part, that is main method class. So this is an essential section of a Java program. So every Java program must have a class definition that defines the main method. And this is essential because main is the starting point for running Java standalone programs. And the main method instantiates the objects of various classes and establishes the communication between them. So the program terminates on reaching the end of the main method. And example of a main class is public, static, void, main, in bracket, string, args. This is how you start the main function. So let us take a sample program now. Class simple. So we are declaring the name of a class here. Open the class. Now within the class we declare the main function. Public static void main, in bracket, string args. Now open the main function. Now let us print any sample printing message. So the command used for printing is system.out.println, bracket open, quotations open, a simple Java program. So whatever you give within the quotations will be executed. Close the main function, close the class.